Hey, it's Mr. Han here. Here are today's notes on scientific notation. Scientific notation is going to be something that we talk about for the next couple of days. And scientific notation is a way to take big and small numbers and write them in ways that it's easier to see and easier to understand. So before I even get into the notes, I'm just going to take a scroll down here, and what I'm going to do is I'm going to give you a couple of examples of numbers that we might want to use in scientific notation. So here's our first one: 25,300,000,000 miles. Now, this is the distance, okay, or the number of miles that our Earth is that we're on. So our Earth is from the closest star that is outside of the solar system. So right here, all I want to show you that it's a very big number, and that's a number that you might look at and be like, ugh, I don't want to write all those zeros, okay? Or here's another example: 0.00 0.000000203. Now here, this is a very small number, okay? And this is the number of seconds, or the time it takes for light to go from one side of the room to the other. Okay, so about 30 feet, that's the amount of time that it would take for light to travel. And light travels pretty fast. Here is a very, very large number. I don't even know how to pronounce this number, but it is a very big number. And this right here is the number of atoms in an average glass of water. So if I had this is not an average glass of water, but if I took about half of it, that's the amount of atoms that are in that cup of water. Okay? And this last one right here is, whoa, I gotta zoom back because it's so big, is the weight in pounds of a proton in an atom. So in science, you might have been talking about atoms, and protons is a little portion of an atom. And this is how many pounds it would be. Now, notice that there is a decimal point right here, and it is a very, 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 oh, I should zoom up. It is a very, very, very small number. This is a decimal point. So it's so small. It's not even a fraction. Well, it is a fraction, but a very, very small fraction. Okay, so these are numbers that we'd look at and be like, these aren't fun numbers to even work with. I wouldn't even want to plug these into a calculator because of the number of zeros there are, and the mistake that I could make by pressing 0 one extra time. So here are some examples that we might use in the real world. Usually in science, we'd be dealing with these kinds of numbers, not on a day-to-day like, oh, how much time did you spend on Fortnite today? Well, I spent about 1,030,000 seconds. No one's going to really say that. You're going to be talking in minutes. But in science, you'd probably want to use a different way to talk about these kinds of numbers. So that's why it's kind of called scientific notation, because these numbers usually are in science. So here we go for our notes. Scientific notation. It is a number that is a number is written in scientific notation if it's in the form c times 10 to the n. Now, that might sound weird to you, but all I want you to know is that c is a number. I could say 6, right? C is a variable, it's representing a number, and it's saying times 10 to another number. Let's say 10. Okay? That's just another way of saying one number times 10 to the whatever power. Okay? So this is how we're going to take these numbers, and you'll see in just a second how we could take these massive numbers that we just talked about and write them in a simpler way. Okay? So this is scientific notation. I'm going to erase our example. So c, a number, times 10 to the nth power. And remember, when it's to the nth power, that means 10 times 10 times 10. Okay? Now, what we need to know is that c is always going to be greater than or equal to 1 and less than 10. So off the top of your head, give me an example that is greater than or equal to 1, so you could say 1, or n is less than 10. So that means that it can be 1, it could be 5, it could be 6. Now, can it be 10? Notice that it's c, and I'm just giving random numbers. These numbers are all greater than 1, but is 10 less than 10? No. So 10 wouldn't work, but 9 will work, 7 will work, okay? So it has to be in between 1 and it has to be less than 10. So here are some numbers that I want you to tell me, are they valid for C? If C has to be greater than 1 and less than 10, does this work? So here, 1.0 is greater than or equal to 1, but less than 10. So right here, this is a valid C. It works. Okay, 1.5, it's greater than or equal to 1, but less than 10. 9.979, that's our third example right here. That number is also greater than 1 and less than 10. I'm wondering, do you know any numbers that will work for us to put into scientific notation? So let's give a number. 5.01, that's going to be in between 1 and 10, okay? 7 is a number that will work, okay? How about 3? So these are just valid C values, okay? These are good, these work, okay? Now, hopefully you're able to see, okay, yeah, 1 through 10. I will give you some examples that do not work for the value C. So remember, C is right here. It's just saying, what number can that be? It has to be in between 1 and 10. So 0.234 does not work. Why? It is less than 1. Okay, so I want you to write this down, why this doesn't work. It's less than 1. 0.234 is a very small number. It's a decimal, okay? Decimal that doesn't even have a actual number value. That's not a good example. I mean a whole number value, okay? 10 is not a valid C value. It's invalid. It's bad because it is not less than 10. So another way we could write that, let's just actually write, it's greater than. It's greater than or equal to. So remember, it has to be less than 10. It can't include 10. All right. 38.625. 38 right there, it already tells you that it is going to be greater than 10. So this is no bueno. Too big. And 1034.2 is also too big. Can you give me a couple more examples? Okay. 5 and 6. Can you give me some examples that might work? Okay. All right. Hopefully you came up with some examples. I'm going to give you 2. I'm going to use 9,999.999. It won't work because it's larger than 10. How about 10.123? That won't work because it is larger than 10. Okay. Actually, let's use another one. Let's do one that's smaller than 1. So let's do 0.012347. Okay, this is too small. It's not in between 1 and 10, so it has to be greater than 1 but less than 10. Okay. Hopefully the C value makes sense to you. If you're able to find a C value, right, a number that is less, greater than 1, greater than or equal to 1, but less than 10, this is going to be a piece of cake. So here, write the numbers in standard form as a regular number. So right here, this example is in scientific notation. 5.6 times 10 to the 5th. Now, I want you to notice that 10 to the 5th is a really big number. It means 10 times 10 times 10 times 10 times 10. And really 10 to the 5th power equals 100,000. Okay? So right here, what we're doing is we're taking 5.6 and we're multiplying it by 100,000, which means that the number is going to be very big. Okay? So what we're going to do is, so let's just read down here. So what this means is that when you have a positive exponent, Okay, remember that the exponent is positive 5. Okay, it's not a negative exponent. That's just one way we could think, oh, it's going to be a big number. You're going to have you're going to move the decimal point to the right. So here, 5.6, it's a value that is greater than or equal to 1, but less than 10, right? 5 is in between 1 and 10. And because it's times 10 to the 5th, we're going to take this decimal point right here, right? That decimal point's right there, and it's going to move over to the right. How many times? 5 times. Okay? So what's going to happen is we're going to take this decimal point and we're going to move it 1, 2, 3, 4, 5, and it's going to come here. And what happens is every time we move the decimal point, there is a 0. So for each time it moves, right, there's 5 times, but there's going to be 1, 2, 3, 4 zeros. Why? This decimal point moved over 1, 2, 3, 4, 5. So really, this number, okay, 5.6, this right here, 5, oh, let's turn on the tail. Oh, what's happening? Right? 5.6 times 10 to the 5th, okay, it really equals 5, oh, that's an ugly 5, 5, 6, 1, 2, 3, 4. And if we count the commas, 3, it's really 560,000. Okay, so right now what we're doing is we're taking this number 560,000, or really we took it from scientific notation and put it in standard form, meaning just regular numbers, no scientific notation. Okay, so 5.6 times 10 to the 5th is the same thing as 560,000. Okay, so let's do another example. 9.425 times 10 to the 7th. Now what's going to happen is we're going to write this down, 9.425. And one of the key things I want you to notice is that C is greater than 1, but less than 10. 9.425 is bigger than 1, right? Or equal, and it's less than 10. So the C value is valid, and it's times 10 to the 7th. So notice that it's times 10 to the positive 7. That's a big number, right? And what's going to happen is we're going to take this decimal point and we're going to move it 7 times. 1, 2, 3. And actually, I'm going to take a pencil. 1, 2, 3, 4, 5, 6, 7. So that decimal point is going to move over 7 times. And for each one of these gaps, we need a 0. Okay? So this number, 4.25 times 10 to the 7th, is the same thing. It's just another way to show a very complicated or big number in an easy way. Okay, so right here, oops, this is 94250, 0, 0, 0. And really it's 94,250,000. Okay. Let's do another example with a positive exponent, meaning that the number is going to be bigger than it looks like. 8.32 is not a big number, but it's going to be bigger because we're multiplying times 10 to the first. So really what's happening here is we're multiplying by 10, and any number we multiply by 10, we're moving a decimal point over. I'll give you a quick example. 6 times 10, well, you all know the answer is 60, right? And guess what happened? There's a decimal point here, and 6, we're just moving that decimal point over 1, it becomes 60. Okay, let's take 77 times 10. Okay, what's going to happen is we're going to have 77, and there's a decimal point here, it's going to move over, it's 770. Go ahead and plug it into your calculator if you don't believe me. 77 times 10, oops, times 10 is 770. So what happens is whenever we multiply by 10, the decimal point moves over 1 time. Okay, so that's just for you to understand what's happening. So we're going to take this number, 8.32 times 10 to the first power. Now 8.32 is a number that's larger than 1, and less than 10. So this right here is a valid C, And what we're going to do is we're going to move the decimal point over 1. So this is going to be 83.2. Okay? And that is our number. Okay? So these are our examples when we have positive exponents and the decimal point is going to move to the right, meaning that the number is bigger. Okay? Now, what if we have a negative exponent? Okay? So here, 7.54 times 10 to the negative third. The exponent is a negative number, and that means that we're going to have a very small number. So 10 to the negative third is a very small number. 10 to the negative third equals 0.001. So you're going to be multiplying 7.54 times 0.001. So 7.54 will become a smaller number. Okay? That means that when you have a negative exponent, you're going to move the decimal point to the left. You're going to move it the other direction. Okay? So 7.54 times 10 to the negative third, we're going to move that decimal point over 1, 2, and 3. That means we need to add 2 zeros to fill in those gaps. And our answer here is 0. And you could always put a 0 in front of a decimal point. 0.00754. Okay? So whenever you have a negative exponent, you move it to the left. Okay? Here, we have 1.2 times 10 to the negative 6. Notice that 1.2 is a number that is in between 1 and 10, so that's good. And we're going to move the decimal point. So 1.2 times 10 to the negative 6. I'm going to move it 1, 2, 3, 4, 5, 6. Ooh, what happened there? 5, 6. So 0, 0, 0, 0, 0. So our answer here is 0.0000012. Let's just double check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So our answer here is good. And notice that I went to the left because the exponent is a negative. And notice that this small number is very small, okay? The number didn't get bigger, it's smaller. And that's what happens when we have negative exponents. Okay. Now, there will be questions where C, right, then this first number that we're multiplying by, C, right, 5.6, what's the C here? C here is 8.32, 7.54, 1.2. So our C is the number that we're multiplying times 10 to the whatever power. Here, C needs to be greater than, must be 1 or greater, but less than 10. So it has to be in between 1 and 10, but it can't equal 10. It has to be 1 or greater. So move the decimal point until you get a number that fits that requirement. So right here, 563 is too big. It's not in between 1 and 10. So what we're going to do is we're going to take the decimal point. Now, if you don't see a decimal point and you have a whole number, the decimal point is always at the end. Okay, it's invisible, but it's always at the end. So what we need to do is we need to move it over 1, 2 times. Why? Because 5.68 is larger than 1 and less than 10. Okay, so right here, you're going to move the decimal point to the left and you'll have a positive exponent. So how many times did we have to move this? We had to move it 1, 2 times, right? So what I'm going to write is I'm going to write 5.68 because now that C value is in between 1 and 10. And I'm going to multiply that times 10 to the second power. And it's going to be a positive 2 here because the decimal point moves over 2 times. But notice that this number is a larger than 10. That's the easiest way for you to know if it's a positive or negative exponent. Okay? So there we go. Here's another example. The decimal point is at the end, right? And we move it over 1, 2, 3, 4, 5, 6. Why? Because we want to get the decimal point where it's 6.45. 6.45 is greater than 1 and less than 10. okay? And it's times 10 to the 6th. We moved it over 1, 2, 3, 4, 5, 6 times, okay? So here is our answer. Now, I do want you to notice that there's always going to be one digit to the left of the decimal point. Notice that 6.45, there's one digit on the left. Here, 5.68, there's one digit. Here, I'll use yellow. 0, oh no, that's not this right here. 1.2 times 10 to the negative 6. So there's always one digit to the left. 7.54, there's one digit to the left. Okay, hopefully I don't need to go through all this. 8.32, there's one digit to the left, okay? So that's kind of a key. So we want to make there be one digit to the left. So we want to move it over 1, 2, 3, 4 times so that there is one digit. So you can see that right underneath. So I'm going to write this as 5.6 times 10. And notice that this original number is what? Is it big or small? Hopefully you recognize that it is small, right? It's a very small number. So times 10 to the negative, our exponent is negative, and it moved over 1, 2, 3, 4 times. Okay? So it's like counting, basically. Counting how many times you move the decimal point. You just need to know where the decimal point belongs. And we need to move the decimal point right here so that there's one digit to the left. So 1, 2, 6.792 times 10 to the negative 2. Why is it negative? Because this number right here is very small, okay? And small numbers have a negative exponent. Small meaning it is less than 1. And if it's large, it's going to be greater than 10. Okay, so that's the notes on scientific notation. Okay, if you have any questions, make sure that you save them for our class. Okay, I'm happy to answer questions. Do not be afraid to ask. This is a new concept. I'm also going to be providing other videos for you to look at to maybe help you if this didn't make complete sense. Okay, your homework is going to be an IXL. So here I'm going to open up the IXL for you. Hopefully you have your notes to the side when you're doing this. Okay, so I'm going to open this up. IXL. Okay, and right here it's going to be, oh, this is the wrong one. I'm going to have you go on G1. So go ahead and find G1. Oh, this is not Math 8, is it? This is pre-K. You guys are not in kindergarten. So 8th grade, and we're going to go find G1. Convert from between scientific and standard. So right here, write 52 in scientific notation. So 52, the decimal point is right here. Okay, and we need to move it over so that there's just one digit to the left. So 5.2 times 10, and 52 is a big number because we're comparing it from 1 to 10. Is it bigger or smaller? And it's bigger than 10, so it's going to be a positive 1. So right here, I'm going to write 5.2, and over here I'm going to write 1. Super. Okay, here's another one. 49,500. We need to move that decimal point over 1, 2, 3, 4 so that there is only one digit to the left. 4.95 times 10 to the, we moved it 1, 2, 3, 4 times. And it's a positive 4 because the number is bigger than 10. Okay, so I'm going to go ahead and put 4.9 and up here, 4.9. 4.9, and right here I'm going to put positive 4. Oh, 4.95. Oops, I forgot to put the 5 there. So make sure you guys do this. If you have questions, make sure you save them, or you could always message me on Neo. Okay, talk to you guys next time.